Welcome to videotutorial.net's course on weldments. First, let me say a couple general words about weldment parts in SolidWorks. Weldment parts are basically multi-body parts built on structural profiles along sketch entities. These segments are then welded together. In order to create a weldment part, we need to create a sketch first, so let's go ahead and do that. I'm going to right-click on the front plane and then select Insert Sketch. Now let's activate the Line tool. And I'll close my profile, create another line here, then right-click and select to close the tool. Let's add some dimensions now. We'll make this dimension 300 millimeters. Accept. 150 here. OK. And here 150 as well. OK. Now let's exit the sketch. And we'll bring in the Weldment toolbar. Let's right-click on any of the tabs and then select Weldments. The new tab appears. Let's click on it to activate it and then activate the Structural Member tool. A structural member is the basic building unit of a weldment in SolidWorks. First thing to do is specify the profile and the size of the structural member. The standard will use ISO, type, rectangular tube, and the size will make it 50 by 30 by 2.6. Next thing to do is select a sketch segment along which the structural member will be created. As you see, SolidWorks created Group 1 automatically. The first path segment appears right here, Line 1, Sketch 1. We're able to create two types of groups, parallel and contiguous. Let me demonstrate. Here's a second sketch segment parallel to the sketch segment I selected first. Let's select the parallel segment. Now two path segments appear under the Settings control section, and they both belong to Group 1. Because this second segment was parallel to the first segment, my group is now a parallel group. I won't be able to select any other segments that aren't parallel to the first segment, and hence I won't be able to select any other entities in this sketch. While we didn't explicitly define the group as a parallel group, our selection of segments determined that it would be. Let's demonstrate a continuous group now. Okay, I've just selected a second sketch segment that's attached to the first sketch segment. Hence, a continuous group has now been created. If I try to select a non-continuous segment, such as this one here, I won't be able to. But I can select the other continuous segments. Let's take this one and the last one over here. In order to utilize this sketch link here, I'm going to need to create a new group. This second group will only have one structural member. Let's return to Group 1. Since this group has more than one path segment, the Apply Corner Treatment option is available. If this option isn't checked, the geometry is going to intersect. Let's take a look at our corner treatment options. We've got End Miter, End Butt 1, and End Butt 2. Under butt type, we've got the option to make a straight cut or a coped cut. Let's rotate the model so that we can see the difference between these two cut types. Notice that when the coped cut type is selected, the gap option is grayed out. Let's return to the miter end type, and we'll insert a 5 millimeter gap. Tab to accept. There's a Gap 2 option. We'll review that in just a moment. We've also got the option to apply a corner treatment to each individual corner. We can do that right in the graphic area. Here we have the option to use End Miter, End Butt 1, and End Butt 2. Check here if you want to apply a unique gap value for each corner. Let's just adjust my distance, and let's close the window. We've also got the option to rotate the profile. Let's enter 45 degrees here. Tab to accept. We've also got the option to position the profile against sketch segments. Here we can simply select any point, and as you see, the profile will move. We can also mirror the profile against the horizontal or vertical axis. We can align the axis along edges, lines, and so on. At this point, I'm going to click OK. Okay, let's expand my new structural member in the Feature Manager tree. We've now got two sketches here. Sketch 1 is the original sketch that we used at the beginning of this lesson to specify the path segments. Under the structural member, we've got Sketch 11. That's the profile sketch. Let's edit Sketch 1. I'm going to add a couple more segments. Right-click and chain. And one more. And let's exit the sketch. Now let's edit our structural member. Right-click, Edit Feature. Let's select Group 2 and this line here. Let me create a new group now. Click on New Group. It'll be Group 3. We'll select this segment. And let's change the profile location for Group 1. And let's check out the difference between gaps 1 and 2. Let's select Group 2. Adjust Gap 2. Let's demonstrate this for Group 3 as well. We'll adjust the Gap 2 distance. Tab to accept. And click OK. Let's take a look at the Feature Manager tree. We've got two new features here, Weldment and Cut List. The Weldment feature sets the weldment environment parameters. In other words, it activates the multi-body environment and allows us to work with common properties available to weldments. Let's take up an example to better illustrate what this means and how helpful this can be to you. In the weldment environment, SolidWorks doesn't merge solid bodies automatically. In contrast, in the weldment environment, the solid body folder becomes what's called a cut list. A cut list is used in drawings. This green icon indicates that the cut list needs to be updated. Let's right-click on the cut list and select Update. Now, as you can see, we've got 7 folders here, and the icon at the top has changed also. If our part contains a structural member of the same size and corner treatment, those structural members will be placed in one single folder. We're going to be looking more at the cut list in a following tutorial. Each of these cut list folders contains structural members of different size and other parameters. Let's go to the Configurations tab now. As you see here, we've got two configurations, as machined and as welded. What this means is that we can create the part as machined, for example, creating drilled holes on one side of the part, etc. However, when we switch to the as welded configuration, those holes are going to be suppressed. What we see automatically is the part as appropriate for a welded configuration. Of course, the more complex your part, the handier this feature is. And this concludes our lesson about structural members. We'll be picking up many of the concepts that we've talked about here in greater detail in this course.